Chapter 23, The Use and Abuse of Statistical Inference, covers a lot of the points that we've already gone over in chapters 21 and 22, with the additions of a few points. I'll try to highlight or tell you when there's a new point that comes up, so you can make sure to put a little asterisk beside it. The two forms of inference we've learned are confidence intervals and hypothesis tests. For either of these to be valid, we need the data to come from an unbiased random sample. The methods on inference for p require a large enough sample size to approximate the distribution of p hat with a normal distribution. This is the central limit theorem that we learned. Also, if you use methods for inference on the population mean mu, use the central limit theorem to assume the sampling distribution of x bar is normal with a large enough sample size. Again, that's the CLT. For confidence intervals, the confidence level tells us how often the interval catches the true parameter in the long run if we were to take many samples from a population and compute a confidence interval from the resulting data for each one. Once you take your one sample and compute a single confidence interval, it either was one of the correct intervals or one of the incorrect ones, so the probability then is either 0 or 1 and you don't know which one. This is why we use the word confidence rather than probability. The higher the level of confidence, the wider the interval. Remember, we used the analogy that if we want to have a better chance of catching a fish, we need to use a bigger net. So if you're more confident, your level of confidence is higher, your range of values is going to be wider. You're going to have a lower bound and a higher upper bound to catch that parameter. The bigger the sample size, the narrower the confidence interval. Remember, the relationship between sample size and the width of a confidence interval is inverse. Larger sample, smaller confidence interval. Confidence intervals are more informative than a hypothesis test because they actually give an estimate of the parameter and they're easier to interpret. So you should always give confidence intervals whenever possible. This is one of the new points that we really want to enunciate here. Hypothesis tests. Remember that they only find evidence for the alternative hypothesis. You never find evidence for the null. You either found evidence for the alternative or you didn't find enough evidence for the alternative. Lack of evidence for the alternative does not prove the null is true. Lack of evidence for the alternative does not mean the alternative isn't true. It's just that we didn't find enough evidence to see that it's true. The p-value summarizes evidence for the alternative hypothesis. A large sample size makes a test of significance more sensitive. You reject more often. A small sample can miss an important difference by being less sensitive. You reject less often. These are new points that we didn't talk about before. Sometimes in practice, maybe a drug company could get a really enormous sample size, maybe 8,000 people recruited into their clinical trial, and you can almost always guarantee that you're going to reject your null and find for your alternative when you have sample sizes so large. This is why we also compare practical significance, side effects, things like that when we're making decisions, because that sample size has such a large effect on statistical significance. This is why you should always report the sample size and your statistic along with your p-value. The p-value determines statistical significance, and the reader can determine whether a result is practically significant. The alpha is 0.05 significance level is a very common choice for a significance level. It is not a better choice than any other level, it's just widely used out of habit. So this set of lecture notes gives you lots of little nuggets to put on note cards before your exam on this topic and to carry through the rest of your career.